So 2.3 we already said hits the x-axis, and those are also called solutions. So starting with then graph number 1, y equals x minus 5. So this is in slope-intercept form. That's our favorite form if we have to graph it. So the thing in front of the x is our m value or our slope. So since there's not a number there, I like to call that the phantom 1. So just remember that we could use 1 there, and then b is our y-intercept, and in this case it's -5. You do need to consider the operation directly in front of that constant. That makes that a -5. So write those two down and then plot them. So the first thing we plot is the -5 on the y-axis as the y-intercept. And then from there, use the slope to find the next point, which is up 1 over 1. Up 1 over 1. You only need 2 points to make a line. My line is just a little straighter when I use 3. And it is important that it's straight. You're welcome to use a ruler here, or just a straight edge of something you have nearby, because we're going to have to note where it hits the x-axis. And again, those are called our zeros. So our zeros in this case, we just have 1. It only hits that x-axis in one spot, and that's at x equals 5. On your Math Excel assignment, it's going to have you write that as an ordered pair. It specifically says write it as an ordered pair, so if you don't, it will count it wrong. And that's not to say that y-intercepts always have to be written as ordered pairs. Sorry, not y, x-intercepts. It just depends on what's the clarification or what the instructions specifically say. Ben?
Ordered pairs, why is there a 0? What's the 0?
That's for the y value since it's on the x-axis.
So technically for those, if we're talking about x, it's always going to be 0 because that's where the line is?
Yes.
Or the
Anytime it's an x-intercept, the y value is 0. And in reverse, anytime we're talking about a y-intercept, the x value is 0. Domain is, if you look the furthest left and the furthest right, what is the domain there? -infinity to infinity, or we can just write all real numbers. All real numbers. And then range, furthest down to furthest up, what's that one going to be? So, same, -infinity to infinity. It keeps going, right? It doesn't end going downward. It doesn't end going upward. So it's going to be all real numbers. Number 2. Is it coming back to you a little bit how to graph lines? Mm-hmm. Good. So then there's the -1. We insert that there. So m is -1 over 1. It helps to write it as a fraction if it's a whole number, an integer value, so you don't forget to go over 1. And then the b value or the y-intercept is 5 here. So I plot the b value first at +5, and then the slope down 1 to the right 1, down 1 to the right 1. So you kind of get the trend of where that's headed. So then my zeros, it's the same one as the last time, x is 5. Or we could write that as 5, 0. And then what's my domain and range? Well, let's start with domain. What's my domain for that one, Michael?
All real numbers.
Good. What's my range for that one, Taylor?
All real numbers.
All real numbers. Okay. keeps going, those arrows indicate there's no stopping point. That's a good indication that there is, the domain or range is not all real numbers if you see an endpoint somewhere along the way. But if there are just arrows that keep going left and right and up and down, all real numbers, all real numbers. Number 3, M is 5/3, right in front of the X there, and then B is 3. Plot the 3. In this case, if we were to go up 5, we would be off the graph. So a better way to do that, to get a more accurate line, would be just to make both of those negative. Since we know negative divided by negative is positive, I could go down 1, 2, 3, 4, 5, and to the left 3. 1, 2, 3. Now you can see on this one, my x-intercept, or my 0, is not exact, so I'm just going to go, okay, so x is approximately negative 1 point, I don't know, 8. Those squiggle lines mean approximately equal to, so that is an indication. I'm not writing an exact number, and I know I'm not writing an exact number here. But
For Math Excel, how would you do approximating that? Like, would it give you the answer, right? Like, how would it know if it's...
I think they're all right on for Math
So you
Excel.
can't- So they won't ask you a question that asks...
Correct.
asks you approximate.
Right. I'm just going to write domain and range on the front here, since it got cut off to the other side. But domain on this one and range, I think we're catching on. It's all real numbers, all real numbers. I'm going to show you the symbol for that, so you don't have to write out all real numbers, all real numbers. It's a capital R with an extra leg. So I'll do that again if you want to watch. It's just 2 vertical lines, and then you seal it off. You don't cross back over. So you make an R with an extra leg, an extra vertical line there. All real numbers. It's kind of nice. It's efficient. Number 4, try that one on your own. Once you have finished number 4, check your answers. And we'll flip. So we had a y-intercept of -1, and then we had that slope of down 2 to the right 5. I wrote x is approximately -2.5. Did anybody else write something a little bit different?
How do you get that from your home?
Because I saw that it hit here. But you could have really had -2.2, anything really, -2 point something. I think when we're sketching on this little graph here, it's a little bit hard to tell. Did anybody have something a little bit different than -2.5? No? Okay. Not often will I give you this many notes. I agree they're kind of long today, but there's a lot to refresh on, and I think because it's review, but we still need practice with it, we can kind of put it all together. So What did you find about domain and range for linear functions? Domain and range, so we just graphed how many? 4 different linear functions. What did you find about domain and range?
Usually all real numbers.
Yes, good. So as long as it's not a vertical or horizontal line, domain and range will be all real numbers. So domain and range for linear functions. And let's excluding horizontal and vertical. Are all real numbers. Now, like I said before, graphing linear functions, our favorite form, there's a few different forms for functions, linear functions. Our favorite form for graphing is slope-intercept form. It's pretty easy. Another one that's also about as easy is called point-slope form. Slope-intercept form is the one, though, that we'll focus on today. Slope-intercept form. The form that's given to us in these questions here is called standard form. And that's AX plus BY equals C. Capital A, capital B, and capital C. So what we're going to do is we're going to convert it into slope-intercept form, and then we'll be able to graph. So we'll start by 5x plus 3y equals 11. Writing it, and then solving for y. This is just like in Unit 1 where we solved equations, solved variable expressions for a given variable. So we want to undo things that are on this same side as the y in reverse order of operation. So subtract the 5x from both sides. And we're aiming at slope-intercept form. So the x component goes first in line. 3y equals negative 5x plus 11. And keep in mind, those aren't like terms, so you can't just subtract 11 minus 5x. And then we would divide both sides by 3. So y equals, for this part, we do want to separate out the two different pieces here of the slope and the y-intercept. So we'll write that as negative 5/3 x plus 11/3. Some people like to convert if it's a y-intercept and it's not written as an integer value. They like to convert it from a fraction to a decimal, which is fine. 11/3 to me is pretty easy to visualize. It's just close to 4, right? 12 divided by 3 would be 4. So it would be 3 2/3. So I'm just going to go 1, 2, 3, and then put a dot right there before 4 as the y-intercept. I apologize for the really small graphs. I'll try not to do that again. So then from there, we're going to go down 5 and over 3. So 1, 2, 3, 4, 5, and then over 1, 2, 3, and draw my line. Thankfully, I don't have to identify the y-intercept on this one, or the x-intercept. I think it's right at 2, though, so wouldn't be too difficult. Next one, if you're feeling confident, try it on your own. I'll be working it out up here on the board. So check your work up here. Slope-intercept form should look like y equals negative 4/5 x plus 4. And then on the graph, the y-intercept is 4. Slope brings us down, hitting the x-axis here at 5. So you have a declining line there, negative slope. Again, this form of the equation is called the slope-intercept form. Where blank is the slope, m, and b is the y-intercept. So let's go ahead and write that down. Y equals mx plus b. And then there's an opportunity to practice a couple more questions down here. I think this is probably one of the most challenging pieces, is just rearranging to the correct format. So solving for y on number 3, we would subtract 3x from both sides. So, and then keep that negative sign in front of the 2y. So negative 2y equals negative 3x minus 16. Then divide both sides by negative 2. And we get y equals 3/2 x plus 8. Is it, yeah, positive, so a negative divided by a negative gives us that positive 3/2, and the negative 16 divided by the negative 2 gives us that positive 8. Next one, subtracting 11x from both sides, we get negative 4y equals negative 11x minus 32. Divide both sides by negative 4. So y equals 11/4 x plus 8. Is that getting more comfortable, confident, solving for y, hopefully? Flip over to the back and we say it again. To find the equation of an oblique line. Oh, that's one word we could use instead of having to say not horizontal or vertical. The word oblique itself covers all of that information. So this is the form. This is slope-intercept form for any oblique line where m is the slope and b is the y-intercept. So 4 questions here ask us to write the equation in slope-intercept form. They give us the slope, they give us additional information, and we have to write it in slope-intercept form. So number 5, the slope is 2. Sometimes it helps to write it out. Oh yeah, slope is m. So I'm going to write out m equals 2. It tells us the y-intercept is 3. Okay, b equals 3. So y equals, so m is 2, we plug it back in, 2x, b is 3, we plug that in. So y equals 2x plus 3. Number 6, slope m is negative 1. It says it goes through 0, 4. So like on the front, how we wrote the x-intercepts, this is just another way of writing a y-intercept. So b equals 4 in this case. So we would say y equals negative 1x plus 4. I'm writing this as a step because that helps some people. Your final answer should just say y equals negative x plus 4. We want to write in the most efficient way. Next, slope is 0. So, in this case, m is 0, b is negative 2. So we could write that as y equals 0, x minus 2. But again, that would not be the most efficient way. 0 times x is 0. So we would just write y equals -2. Which would look like a horizontal line, which is why this doesn't look like slope-intercept form. Lastly, m is -3/5. B is the origin. So what does that tell us about the y-intercept? It's in the very middle of the graph, which is 0. 0, 0. So our y-intercept would be 0. Y equals -3/5 x. We could write plus 0, but anything plus 0 is that same thing. So we just most efficiently would just write that as y equals -3/5 x. A few questions here to help us practice looking at a graph and writing the equation. So with number 11, so we always want to start by kind of identifying that starting point, that y-intercept. So this one is at 2, b equals 2. And then we can, from that point, calculate the slope. To find the slope, you just want to find another number that we can rely on. So it should be exact. So we can find 2, 3, where it goes up 1 over 2. Up 1 over 2 is how we would write that as a slope. And then fit that into our slope-intercept form of the equation. Y equals 1/2 x plus 2. Number 12 hits at 1, 2, 3, and goes from 3. It looks like another point is right next to it. Now maybe you picked a different point that was an exact point, and that's okay. You just might wind up having to reduce your fraction, your slope fraction. So the b value here is 3, and the m value here is down 1 over 1, so -1. And you can write over 1 if that helps you, but ultimately that would be written as m equals -1.
Wait, how's it -1?
Okay. And then y equals mx, so -1x plus 3. And again, like we just saw in our previous example, we write that as y equals -x plus 3. Next one, what do you think that goes through? My eyes get cross-eyed a little bit on these small graphs. I think it's 2. Anyone agree?
3.
You think 3?
I think it's 3. Yes.
Okay, thanks. We'll go with 3. I need stronger glasses. So b is 3. And then what's the slope? Up 3 over 1? Yeah, I like that one. Up 3 over 1, or just, no. Up 3 over 1, which is just 3, so y.
Mark if the 3 is,
It would just be different. We just have a negative sign.
but that's still technically the right answer.
Did you go down 3, left 3?
Yeah.
Left 1?
Yes.
So you had negative and negative?
Yes.
Yeah, so you wind up with a positive 3 as well.
Ah,
Good question, though, because you could go in reverse, but if you're going in reverse, it would be 2 negative. So y equals m is 3, 3x plus b is 3 also in this case. We're going to skip 14 through 16. I think we kind of get the point. I'd be glad to go over those with you if you'd like. And then we have 2 special cases, right? The vertical line and the horizontal line. So number 1, I think of horizon when I forget. Horizon is just the flat line. Horizontal lines have a 0 slope. Someone drew this diagram up here that they had learned where the this is like your ski slope, and positive goes this way, negative goes this way, 0 is horizontal, and undefined is that way, and I help care to remember, so whatever helps you remember. Horizontal line is like easy to walk, it's 0 effort. That's how I remember it. And then to write that as an equation, it only goes through a y value. It has no slope, so y equals 0x plus what? In this case, it's 5, right? And that's your equation of your line. And we don't call that slope-intercept form so much. Number 2 then is a vertical line, and vertical lines have undefined slope. The run is 0, right? It doesn't go over any. So that would mean like a 0 in the denominator, which a 0 in the denominator makes an undefined expression. So in this case, we just write x equals whatever x is, and in this case, it's -5. The fun thing is, once you know this, it makes these questions super easy. Horizontal line. Hey, what's the equation of a horizontal line? Horizontal, that's the one that just goes through the y-axis. That's just y equals. What's the y value here? -3. Done. Vertical lines, similar concept, but this is the one that only goes through an x value. Our x value is -4. So that's the equation. That's it.